What do you think the word optimize means?
Yeah. Probably like yes, used out of.
Well, if it's that kind of thing, use out of, yeah, the best. I like what you said, the best use of it. Yeah.
Deciding best method.
It's not best method actually. No, it's not quickest. It's got nothing to do with your method. You can use whatever methods. But if you look at it, are you seeing practice 4 in front of you? Right? Optimize the objective function, right, given the 4 constraints. So, any ideas what it means? Jackson has said something about make the best use of that. I would go with that. It's not quite what I want, but it's still scribbling in my book. So best, what do you think that could mean with p equals 50x plus 25? They come back to me at the end of the year and then essentially go to someone else. So
E is equal to 50 multiplied by x plus 20.
yeah, so I'm going to find an x and a y value that put into that. Yeah. How many x and y values can go into it? Yeah. An infinite number. Yeah, we can put an infinite number of x and y values into that would give me an answer for p. Right?
Sorry.
Sammy?
Yeah, I'm sorry.
Matthew. Okay, so that's part of it. Now we've got these constraints. There are 4 inequalities, and what are they going to do? They're going to identify a region where I'm allowed to pick my x and y's from, right? As Matthew said, I'm only allowed x and y's that suit all of these. So you have just been shading regions. Remember that last question? There were only 6. When I said 6 coordinates that you were allowed to use, right? Okay, well, let's just say there were only 6 coordinates available in this region. The coordinates are an x value and a y value, yeah? What do you think if you put the ordinate pairs into this equation? Do you think p is going to be the same every time? Or what do you think the word optimize it means? Not accurate. Don't misuse that word all the time. Is it? Well, it will change, but what do you think the word optimize?
Make it better.
What do you mean by better, Ben? Nope.
Make it more simple.
That could mean optimize in a different sense, but in maths, it's not what we're looking for. It's think about what Jackson said.
Yeah, the best value.
To do what? The best for what? Here you go. No. Okay, so I thought this would be simple. Obviously not. If you optimize something, you make it the best it can possibly be. Yeah. But in this case, best doesn't necessarily mean best. Best could just mean optimize actually means highest value for. When it says optimize, it means make p as large as it can possibly be. So you are going to be limited to certain values of x and y, that when you put into this, you will get different values of p. The word optimize simply means which x and y pairs make p the biggest it can be. Got it? All right, so should we, let's write that down. So we are going to, in your maths book, you're going to write this. So optimize, what is it? P equals,
Given the fourth.
what are the constraints?
X plus 4 y negative 4x plus 6y. 0 is greater, it's less than less than or equal to 15. Y is greater than or equal 0.
Okay.
Actually, the first two, I said it wrong.
The first two and the third and the
So
fourth.
that one should be that way round. That one should be that way.
And the fourth one should be.
That one should be y should be less than 0. Okay. So basically, these constraints tell you there are only limited numbers of x and y values that you're allowed to use. So this will give you the region. You've been doing one where you had 3. This is now 4 or 5 even, because you've noticed from the 0 to 15 one that that's a double line, right? So what's this going to look like? Now I could ask you to graph this by hand, but it would take you a long time. So what do you think we're going to? Yes. So before you can get yours out, let's have a look. I graphed Desmos, and do you remember when I said if you shade in what you want to keep, it looks a mess. Alright? So we wanted to shade in what we don't want. But Desmos, I've been trying to look for it and it doesn't have a way of inverting, okay, the inequalities. Alright? GeoGebra does, but it's actually a little bit harder in other ways. So what I'm going to get is, do you think there's any particular way, looking at them inequalities, is there any way that we could invert it without being clever about it? How can we do it?
Flip the side.
Oh, perfect. So if I flip these signs the other way around, so on Desmos, look, if I, hopefully it will let me do it. Right, if I click there, look. Oh, what was that? A 0. If I click here, I can get rid of it. Now on the keypad down here, so which way round was it? To the right, pointy to the right.
Yeah.
So we're going to put it pointy to that way round. That's the way it was. So we want this way. Now that's shading the opposite. Now, I didn't want to do it like this because I'm aware that that might be a bit confusing, that you're actually sort of doing the inequalities wrong. But I showed you how it looked when you did it the right way around, and it's a bit confusing. Now, if you're okay with, because the region is basically this one here, yeah? It's in the video, it will be this point here, right? This section. Now, if I swap them around, I literally just have to do, so that one's to the left, so I'm going to do to the right. This one is to the left, so I'm going to do to the right. You literally, I would type them all in first correctly and then swap them round. And what you get, look, do you see now? Do you see now why it's easier if you shade in what you don't want, right? So this is the region that I'm allowed. But the only way to do that on Desmos is to flip the signs to the wrong ones. Alright? Well, that helps you understand. Now, what values of x and y am I allowed? Well, all of these are and equal to. Okay? So I'm allowed anywhere on the lines as well as inside the region, yeah? Is there any limitation, like I'm only allowed whole numbers? Can you read the question? Does it say only allowed integers?
No.
No? So I'm allowed anything now. Now this is where Desmos is quite useful, because you would have to, without a computer, solve for where all these lines cross. But we've got a computer. So we're going to optimize it. Now, any ideas where you think the best places would be to pick an x and y value that you think is going to give the biggest value for p? James?
Probably like higher access or well in terms of actual
So yeah, so in this region, what do we think?
in between. Because
We think in between.
if you go too far to the right on the x-axis, you'll have very low y, but I see it's just
Okay, now I get you. So, yes, you go.
I think higher on the x because I'm taking x by 50.
Okay. Ah, I do like that. I like that thought. So, if you think about it, everyone. Sorry, I can't. I like that, so I'm going to mention it here. Look, which variable has the greater impact on P?
The 50.
The 50x. X gets multiplied by 50, right? Y only gets multiplied by 20. Therefore, the x has the biggest impact. What we do then is we look at our graph and we kind of say, right, let's start with the vertices, the extremes of the group, of the region. So I'm going to click on this point, and that point you can see is,
5.727.
do you want to write those down? So x equals 5.727. And y equals 3.818. Written it? Next one down here, 21 and 0. Alright, x is 21, y is 0. And over here, it's going to be 0 and 0. Well, that's a big no-no, isn't it, really? So really, what we're going to do is we're going to compare that one and this one and see, and then we're going to talk about, well, do we think somewhere in between, because you've already said x is the bigger input, but is having 21 x's and no y's better than having 5.7 x's and only 3.8 y's?
No.
Do we think further along here? Yeah, it might be. Right, so we've got, so what we're going is we're going for the extremes. Are all these in there? Are they all correct from the question that I should do? That's 4y minus. I thought there was another line, but there was x is 0. Oh no, there is look. No, we've got a mistake. What's happened? There should be.
That's right.
Where's the 15?
Yeah, where's
X must be great. That should be.
where's the blue?
So let's try that one again. No, we should. I thought there should be that line. That 21.0 shouldn't be right because actually, what do we have? X. Now that's an important thing. Actually, we can't do the way I wrote it. We have to do it separately. So we want x less than 15. So we're going to put x is greater than 15. Okay, and then another one we have to have x is less than 0, and that's how we separate that one. All right, so be aware of that one. Okay, that's why you have to understand. Now that changed it a little bit. So that 21.0 is not even in the region. Sorry about that. What's this one then? So this would be 15 and 1.5. Write that instead. Is it worth going below 15.0? Well, that's the same number of x's but no y's. So actually, we already know that's going to be a better point, don't we? So really now it's 15, 1.5, and then this one up here is 5.7, 3.1. So, have you written all those down for me? Okay. So what did we have? X equals 15, y equals 1.5 was one option. Let's work out what P is. So P would be 50 times 15 plus 20 times 1.5. Can you tell me what P would be for me? Got your calculators out? 780. Okay. And our other option was x equals, what was it, 5.7 27 and y equals. I'm a bit skeptical about those numbers. I did that graphing yesterday and left it up, so maybe it's worth double checking this question. But let's try that again. 50, P equals 50 times 5.727 plus 20 times 3.818.
362.71.
362.71. So, we already think, well, we know that this point here is a bit better than the other one. Let's just do another little bit of interpretation analysis of what we've got, which is, do we think that moving down the line is going to help us?
I think it points at x-axis. So 10 on the x-axis.
10 on the x. 10 and 2.75. Why don't you try it? I think it's 10 and 2.75. Try that, see whether that makes it a higher value of P. 10 and 2.75.
It's 400.
So we've already found out that really we want to maximize the x as much as possible, and then the y value, every drop in one y only drops it by 20, but every drop one in x drops it by 50. So really this point here is going to maximize, or correct word, Nathan, is optimize. We good? All right. So over to you. We've only got 15 minutes, but that's good. You now are going to do the other ones in that exercise. All right. I think so. At least questions 2 and 3. And you can use your Desmos. Get your laptops out. If only one of you has got one, you can work together on it. Just check. All right. But what I would like to see, although I haven't done it on this page, a little sketch of what you see on the Desmos screen, please. Once you put them all in. Okay?